Just water treatment, switching gears on you here. Again, water is a reactive substance causing corrosion, spreader materials, and microbiological bacterial fouling. So remember when we were looking at the chillers and they had the one chiller opened up, so all the little tubes in there? If you consider every tube in there is good for 1 ton of conditioned air, okay? Every tube. So when those tubes become foul with calcium, foul with sediment, what happened is the exchange between the refrigerant and the water process between the tubes now becomes compromised. So what you're doing is you're running more refrigerant in there to maintain that temperature, which increases your electric load on the motor and also the systems and components. Okay, so what we're going to look at just some basic water treatment services. Okay, one's air conditioning systems. We reviewed those. Chill water. Chill water typically is going to be a closed system. You will have makeup on a chill water system, and you usually monitor your makeup water meter. So you're going to have some losses, some leakage, and it could be a couple gallons a week. But if you start to notice that the water backfill, okay, you're backfilling with, say, 100 gallons of water, then that's telling you that a coil somewhere within your infrastructure is leaking, or maybe there's a bypass valve. So then at that time, you're going to go start looking at your drains coming off your air handlers and seeing if you are losing chill water. Other item, too, is they dye the chill water. They'll dye it a bright red or a bright purple. And the reason for that, if you do have any leakage past insulation, for instance, it'll turn that insulation that color. So it's telling you you've got a leak there. Okay, so that's another maintenance precaution in regards to that. Condenser water and cooling towers, we saw that. That's what I would consider the exposed water system. So that's exposed to the elements. So any dirt, contaminants, debris that's floating around or flying around in that particular case is going to be absorbed basically through the water. So you're going to have filtration systems. And that particular water, because it is open to the air, is going to be subject for contamination. So algae, okay, in some cases it's going to have microbiological type impurities within that water. And comes with that is corrosive. Okay. So all I want to do is maintain that. Okay. Free cooling, as we talked about the plate and frames. Okay, in that particular case there, I'm using cooling tower water as well. Again, open to the elements. Some cases there is just reverse. Instead of contaminants, it's freezing. So in that case there, I can freeze the coils, right? And once I freeze the coils, one, they'll split, and then I've got issues once it thaws out. So in those particular ones, this temperature control is going to be important. Heating systems, closed loop typically, humidification systems. This one here is a big culprit of, I would consider, calcification and also corrosion from within your air handlers. We didn't see an air handler. We did see the cooling towers. But when you humidify the inside of the air handlers, what happens with moisture is in some cases it will contaminate and attack the metals. So again, you go back to regular maintenance, scraping it down and epoxy coating the inside of the air handler. Again, I'm optimizing the life of that air handler as long as possible. Potable water would be another water treatment system. Typically at the city side, they're going to perform the maintenance on that potable water. So when I get my water from the city of Scottsdale, typically I'm pretty well assured that one has gone through an inspection and also regulatory requirements for that water before it's piped into my facility. Then the last item is corrosion coupons. We didn't see any, and I forgot to bring any from my facility. But the corrosion coupons is what the water treatment companies use to determine the level of contaminants and the level of chemicals in your water. So they'll put a copper coupon, say for instance, from within the path of the cooling tower water, and they'll go back and assess how many mils has the acids and the biocides that they're using for that is actually etched from that coupon. So it'll give you an indication of the copper tubes inside your chillers. So it's another predictive maintenance program. And then I asked them if they could show you the anodes inside the bells on each side of the chillers, whether they put the anodes as well, because usually it'll attack the anodes before it'll attack the bells in regards to that. So again, another predictive measurement. So when they mentioned that they do all the water treatment in-house, I was pretty impressed because that's a science when it comes down to that. So I outsource mine, okay? And then the principles of water treatment, again, include physical and chemical methods. So some physical is just maintaining. Typically in a cooling tower, you're going to have a sand filter like in a pool. And in fact, you had the one in the little cart we saw with the NRG. So what you do is you go down into the sumps and you basically vacuum out all the sediment. and then it'll go through a sand filter, and you'll run it right back into your sump. Some cases you can have a reclamator, and the reclamator actually takes your blowdown water from your cooling tower sumps. It's a big RO unit, and it'll run it through the filtration systems, and it'll inject that water right back into your cooling sumps. The reject water is the highly concentrated water is put in a holding tank, and then that's run back into the sewage system. But again, you'll get 2 or 3 more cycles out of your water with that particular process. So physical. Then, of course, chemical is treating the water with chemical types. Typically biocides, in some cases anti-foam, and also sulfuric acid is a typical use. They also have electronic controls now on cooling tower systems where they actually electrify the water. So they energize the water to collect the contaminants. Okay, so they'll attract them that way. Okay, to ionization system. Okay, in some cases. Open water systems allows introductions of soils, as we talked about, contaminants. Okay. Makeup water, that's the makeup water coming back into your cooling towers and your closed loop systems. Again, you got to keep the balance, pressurization of the water. And then the water circulation. In Arizona, typically heating systems, right about now, they're being idled and shut down. But still, you'll have a recycling pump, and you'll continue to recycle that heating loop to keep that water constantly flowing so it doesn't stagnate and stay in the line, and of course cause additional corrosion, okay, from within the line and systems. Okay, so just some typical water treatment type terminology: corrosion, okay, metal reactions to exposure, different types. Okay, controlled by adjusting alkalinity, okay, and mineral deposits. Okay, here in Arizona, primarily it's since our water is so harsh, okay, is we have a lot of, I would say, calciums and a lot of minerals in our water. And typically you'll see those in the cooling towers because they look like salt. They look like a real fine, it looks like dirt, really what it looks like when it dries up. It looks like mud. But that's what's coming out of the water. So once it hits the air, a lot of the suspended solids, if you will, now remain, and they stay either in the media or in the bottom of the sumps, depending on their weight and so on. But if you consider everything that's on the cooling tower side is actually goes through your chiller, through your pumps, and then back to the cooling tower. That's why water treatment is so critical in regards to that. Scaling, that's mineral deposits, typically calcium. Okay, in some cases you get carbon and phosphates. Some water systems you can also treat with phosphates as well. We did that with our drinking water systems in Scottsdale. And that one there is that we coated the lines with that phosphate. Again, extend the life cycle of that particular line. Okay. General disposition such as debris, okay, dirt and suspended solids, typically with your sand filters and strainers. Okay. And microbiological fouling. These are the items that you really can't see with the naked eye, but they still affect the inside of your equipment and systems. Algae in some cases. Fungicides would be another one. And with the high efficiency chillers, what they have is the rifle tubing. And the rifle tubing has micrological swirls, if you will, in the tubing, and that's for the water and the refrigerant on the outside. Typically, we're looking at the rifle on the inside. Once the rifling gets any type of sediment in it, what will happen is you'll start to pit, and then they'll start to basically corrode the copper. So anything where you don't have water movement, it's a suspect for corrosion. That's why when they do the eddy currents, they're actually checking for the thickness of those tubes in the walls. And of course, if it gets to a certain level, they'll plug those tubes so you don't have any more water. It keeps the integrity of the refrigerants. But again, every tube you plug, it reduces the efficiency of that particular unit. Okay. And providing proper chemical treatments. Okay. Typically, as I mentioned before, I was surprised that ASU did it. Typically, they're contracted out just for the liabilities, okay, and the cost of replacement. Okay. Access to resources and technologies such as chemicals and cleaning agents, training. Okay. Ability to provide technical and scientific reports. So if I have a high level of fouling, say in particular in a central plant, I can call upon the water treatment contractor to actually give me a report analysis on what's causing it and how can I minimize that. Some cases that maybe you need to put an RO system, a headline in regards to your city water, okay, or maybe modify the chemical systems in that particular one. Okay, and then typically they're going to have knowledge and systems and controls, okay, for monitoring. So some are digital, and some are in regards to They're actually used off the internet, so they're wireless systems. So if I have a high level of maybe chemicals such as high levels of biocides, or in some cases if my alkalinity is extremely high, it'll page me on my phone and text me telling me that this particular cooling tower, okay, there's an imbalance in regards to the chemicals. So with that, it'll also text me back telling me what the systems, because they're automatic, are doing to take care of that. Other items would be in regards to the suspended solids. If you put an infrared system in that particular unit. So again, everything's going digital. So it's not so much for the naked eye anymore. Where you get your little beaker and you look at it in the sunlight. Typically, everything now is being done digitally and electronically in regards to monitoring needs.